Good morning, everyone. Good afternoon, good evening, wherever you may be in this part of the world. Welcome to another session of my presentation series. And this time, the topic is electrical power generation utilizing geothermal energy. My good name is John Kweku Amuotu, and I've been a professional electrical engineer for the past 31 years practicing in the United States of America. Now, let's talk about some logistics here. If you go, this is my YouTube channel, Work and Happiness, talking to the engineer, and basically has tons of presentation material that will help you as a young engineer, as a developing engineer, as a mid-career engineer, as an experienced engineer, as a consulting engineer. And sometimes, like I said, experienced engineer and consulting engineers, we all need quick refreshers, and this can be a quick refresher for you. Okay, so if you like my presentation, don't forget to select the like button, right? And don't forget to share that knowledge. Okay, so you can also subscribe to my YouTube channel, but before you can be able to subscribe, you need a Gmail account or Google account. Right. Once you have that, you should be able to create a YouTube channel, and also be able to subscribe to my presentations. Re-emphasizing what I just said in the earlier slide, this is my YouTube channel. It has tons and tons of presentation material, and you can go there. You need a Gmail account, right? You need a Gmail account in Google, right? Then you should be able to have the opportunity to basically subscribe to this YouTube channel. And if you like my presentation, don't forget to select the like button right here. Okay? And don't forget to share the knowledge. This is the subscribe button. So now let's talk about the basics of geothermal energy, right? Okay, so basically you have far beneath the Earth's surface, let's say about 5 to 6 miles, right, below the Earth's surface. And basically you have a hot lava or magma. Just like, volcanic eruptions, right? Similar, so you have a hot magma that is basically embedded in the Earth's surface, 5 to 6 miles below the Earth's surface, and for so many years, and after a period of time, it's basically erupts. So this hot magma that is basically lying over here, and as you know that, as you have rain and all those things collecting onto the Earth's surface, right? If you have a rain, constant rain or periodic rain, basically what the magma does is basically it heats, because think about it, the heat that is generated from the hot magma is about 50,000 times hotter than even what is on the sun's surface, right? Well, that is emitted by the sun. So this hot magma basically heats all the water that is collected in the reservoir here beneath the Earth's surface. Like I said, 5 to 6 miles below the Earth's surface. So basically, it turns into steam, right? And basically, this steam is embedded below the Earth's surface. So basically, our goal is basically to achieve a geothermal energy. We need to basically harvest this steam that is far below. So basically, piping is drilled down, just like you're drilling oil, right? Below, and to where this reservoir is located. And basically, this steam can have the opportunity to flow. Though, it travels, like 5 to 6 miles, through this pipe, definitely, the pressure is going to drop. So as it gets here, then you can have a high pressure steam come out, right, and basically be piped. It can go through, a couple of reheats to make it a little bit drier before it gets into the steam turbine. So this slide basically gives you a much more detailed descriptive cycle of geothermal energy production, right? Okay, so like I indicated, right, far below the Earth's surface, like 5 to 6 miles, And sometimes, depending on the geographic region of the Earth, it could even be more than that. It could go into, let's say, 10 to 20 miles, right? Okay. So you have a hot magma that is right here, right? That is just, it's basically, bedrock over here. So, like I told you, basically volcanic eruptions are all based on this hot magma that is embedded, and with time, basically this hot magma builds up pressure and basically start flowing, then it erupts. So that's how you get volcanic eruptions. Okay, so then you have rain, right? This is the beautiful cloud. Then you have rain that is basically falling, and basically this rain, you have a permeable layer of rock over here, right? So basically this rain basically collects in this permeable layer of the Earth's surface, far below the Earth's surface. So this hot magma basically heats this water, right, to form steam, right? That's probably about 60 to 70% steam and basically about 30 to 40% water in it. So it has some saturation of the water. It's not dry steam, right? Okay. So then our goal is basically, just like you have oil reserves, right? Okay. So basically, this becomes a steam reserve, which basically has some saturation of water in it. So piping is basically sent, all the way 5 to 6 miles below the Earth's surface, right? It's drilled all the way, just like you're drilling, uh, oil, right? And basically piped into steam, water separated, right? Okay, so once the piping reaches that level where the moisture, where the steam is located, right? It definitely is, then it starts, due to the pressure that is built up. You'll see that the steam start flowing right into this steam separator. Okay, so once it gets to the steam separator, right? Like I told you that this steam, it has some composition of dry steam and wet steam. Okay, so the goal is basically to get the dry steam to flash over and basically be able to be piped into the turbine. So the high pressure steam comes into the high pressure section of the steam turbine, right? Because the steam is drier, right? So basically it rises up and basically flows into this piping into the high pressure section. Right? On the other hand, the low pressure, right, steam basically has some wetness in it, right? Like I told you, the steam that is coming from beneath the surface has some dryness and also has some wetness in it. It is not pure dry steam, right? So it has to go through a separator, a steam separator, to separate the dry steam and the wet steam. So the wet steam basically collects below and flows back here, where basically it flashes, and basically it creates a low pressure steam that flows to the low pressure section of the steam turbine, right? And sometimes, to get it a little bit, drier, it goes through some, depending on the geothermal energy configuration, it goes through some reheating, before it comes into the low pressure section of the steam turbine, right? Okay, so far below it is a condenser, right? Okay, so the condenser basically has cooling water, basically, that basically it flows through the walls of the condenser. So as the steam basically, after passing through the turbine, because once the steam hits the turbine blades, it rotates it, right? So that's how, that constant hitting of the steam on the turbine blades, that's how rotational energy is created. Mechanical rotational energy is generated before electrical rotational energy. Okay, so once the steam gets into contact with this cooling water that comes in, basically it collapses into water, right? Then basically it goes through cooling water, a cooling tower, right? Okay, so as you can see over here, you have a cooling tower, depending on the configuration of the plant, right? Okay, so You have a cooling tower that is here, where basically you have the hot water pump that pumps the water through the cooling tower, and basically you have air that basically flows, and fans that basically flows, and to basically extract the heat from the water. Then after that, right after that, basically it goes through the re-injection process, right? It comes back into this. So this is the re-injection point, right? Okay. So, and even below that, there's the low pressure section also has a re-injection. So there are multiple re-injection points that basically re-injects the cool water back into the reservoir to be heated, by the magnet. So that's how the cycle. So after that, basically, you have the turbine, you have the generator, basically rotating, then basically generates the electric power, and basically you have a transformer that steps up the voltage up to whatever voltage, so you can have a terminal voltage of, let's say, 13.8 kV or 18 kV or 21.3 kV. That steps the voltage up to 105 kV, 230 kV, 345 kV, 500 kV, 765 kV, and now we have ultra high voltage that is about 1100 kV. Okay, so, and basically it goes into the transmission system. So this is the high transmission system, because for where it travels for thousands of miles before it gets into a sub-transmission substation, where basically the voltage is stepped down to, because the goal is basically to achieve distribution voltages. So it has to go through sub-transmission, then from sub-transmission go into distribution substations. Okay, so remember, I told you that, far below the Earth's surface, right? Okay, so you have, let's say, like 5 to 6 miles, right, below the Earth's surface, you have hot magma, right? Right, and you have rain that collects into this permeable rock, and that allows our rain to saturate it, collect our rain water, for so many years, right? Okay, so the hot magma basically hits the rainwater that is far below the Earth's surface, like I'll say, and estimated for, let's say, about let's say 4 to 5 miles, right? Okay, so this turns into steam, right? As you can see, the bubbles over here, right? It's a mixture of steam and water. It means that the steam is saturated, it is not pure dry steam, right? Okay, so it's about 60% dry steam and 40% water. So they draw the piping here all the way from the top of the surface of the earth, right? Okay, so to harvest this steam, right? Okay, so once, just like, they do that for oil reserves, right? Okay, so this basically is a whole reservoir on its own. So once the piping reaches this level, basically due to the pressure buildup of the steam, eventually, basically the steam start flowing through the piping all the way, just like, oil reserves. And once it gets to the top of the surface, definitely the pressure is going to drop, right? So then it goes into this steam water separator, right? Steam water separator, tank, right? Okay, so then basically, you have the dry steam. Basically, that one is going to flash over, and basically it goes into the piping. So the dry steam will be achieved. It rises up automatically. And the one that is saturated with water goes to the bottom of the tank for it to go into another tank, right? For it to be separated, and sometimes it can get reheated. So this goes into the high pressure section of the turbine, right? Then, the low pressure, this one creates the low pressure steam, right? And that also goes into the low pressure section of the turbine. And you have the turbine that is integrated to the generator. So as the steam impinges upon the turbine plates, basically it starts rotating and basically start generating electrical energy by converting the energy from mechanical energy to electrical energy. Okay, so now let's talk about some, logistics for the final. Okay, so if you like my presentation, don't forget to select the like button, and don't forget to share. And this is my YouTube channel, has tons of presentation material. And for you, can subscribe to my channel. But for you to be able to subscribe, you need, this is the subscribe button. Okay, you need a Gmail account or Google account. Before you can be able to subscribe. Okay, so with that, that comes to the end of my presentation, and look out for more interesting presentations that will come your way. Thank you.